Hey LAN party gamers, and welcome to a personal rig update. This is going to be my LAN party rig. Now if you've seen this rig in person, it used to be an AMD A10 FX series processor, which was an APU, which means that I could combine the onboard graphics that were built into the chip with a GPU, or use the GPU by itself, or even the CPU by itself, and it was a decent gaming system. The biggest problem with the old AMD chipsets were that they couldn't stream worth a damn. Now that's all changing as we're unboxing today the Ryzen 3 CPU. Now we're going with the Ryzen 3 because it's a true quad core. I don't really need simultaneous hyperthreading or anything of that nature. I don't need 8 cores, and I sure as heck don't need 16. This is going to be a LAN only rig, and I might do some light streaming on the go. This is also going to be a system that we do VR while we're at locations. So when we're at events like an anime convention or a tech conference or whatever, and if we're hired to come out and do a VR display, this will be the rig that we power it on. Now before we go too much further, I'd like to give a big shout out to ASRock for sending us a review sample of this ITX Fatality AM4 motherboard with Wi-Fi. Without this board, we would have a very hard time or nearly impossible finding it. It's out of stock everywhere we look, and it obviously costs a pretty penny because of how new it is and how fully featured it is. Obviously, this is going to be the closest thing to a full-size motherboard you can get in this small form factor, and it's awesome to see companies getting smaller and smaller with these things. And you know how much we love the small form factor here at San Diego LAN. It allows us to get out to LAN parties and show them off. So cool on you. Thanks so much, ASRock. I also want to give out a big shout out to Silverstone for helping me replace this old AM3 bracket with an AM4 of the same kind for this very particular CPU cooler. So that helped us out. We didn't have to mill into this one or anything like that. Those were provided by ASRock and Silverstone respectively. So thanks a lot for sending those our way. So as I mentioned before, we're using a Ryzen 3. We're using the 1200 because in studies it's been shown that the 1200 can overclock just as much as its X counterpart. So we're going to be trying to get as close to the 4 gigahertz mark as we can. To achieve that, we're not going to be using the stock Wraith cooler, which comes in the box with the AM3 motherboard. This cooler will be put to the side, and we'll save it just in case someone needs it later. What we're going to be using is the original cooler that I got for this case. Now the case we're using is a Raven RVZ01, and we're using the RVZ01 as opposed to the 02 as it gives us an extra 2 liters of space on the inside of it. That should be plenty enough size for the cooler that we're trying to use. So we're going to be pulling 120 millimeters worth of air down onto the processor from here. And on the GPU side, we've got 2 more 120 millimeter fans blowing right onto the cooler. All of the other fans in the case, including the GPU fan, we're going to be exhausting the air out the back. Now for a GPU, we have it mounted on our bracket here already. We have a Radeon RX 480 8GB edition. And this is a blower style, so because I wanted it to be, 1, fit inside the case well, and 2, I wanted to be able to, the power requirements, because we're only using a 450 watt SFX PSU. On the back side of the GPU block here, we have 2 PNY 480 gig solid states. We're going to be running this on RAID 0, giving us just shy of a terabyte of our C drive, which is going to be programs and Windows, of course. Now for storage, we have a 1 terabyte spinning disk drive. This will be for things like recordings of gameplay footage that we have, or any kind of other pictures, videos. If I'm shooting at a location that day and I want to offload that from the camera, that will be what the spinning disk is used for. But for everything else, the games, they're going to be on this RAID array. Now let's take a quick look at this motherboard real fast. It has 2 DIMM slots. We're rocking 2 8 gig sticks of DDR4 2400 from Patriot. We've got obviously the Ryzen 3 there already mounted in. We use the same socket style as AM3. It's got a 0 impact force lever and a small golden triangle on the corner telling us where to line that up on the motherboard. So that just goes in the socket as such. Then you just put the arm down and your CPU is in place. On the I/O side of things, it comes with your 2.0 header USB ports. We have a combo PS2 port, 2 HDMI outs, 2 USB-Cs, 2 USB 3.0 ports, a gigabit LAN, a fully featured audio card with 6 outputs, or I should say 6 in and outputs, and 2 Wi-Fi antenna ports to put in the included Wi-Fi antennas. On the other side here, we've got a metal reinforced bracket for your video card. That's really reassuring. I know that this is not going to break or wear anytime soon. On the back side, we have 4 SATA ports for our hard drives. We're going to be using 3 of these, of course. We've got a USB 3.0 header, USB 2.0 headers. We've got an audio front header. We have the plug here for the battery. And then, of course, the 24 and 8-pin connectors for the power supply there. So that is the rundown of the motherboard itself. We've gone ahead and removed the stock cooler that was part of the board as it came with, and we'll put that to the side just in case we need it for another build. This is the CPU cooler base plate that comes with the CPU cooler that we were provided, that we had originally used in the previous build, and now we have an AM4 bracket here. This is the AM3 bracket, this is the AM4 bracket. They're very similar looking side by side, but the holes line up just a little bit differently. So it was very cool of Silverstone to send that out our way. So right now we've got the processor in, and you saw us unboxing that. It comes with the Wraith cooler, the Ryzen 3 processor, of course, and the Ryzen 3 sticker. We're going to be putting that on there, of course, replacing the one that we had on the case originally from the old FX days. And we're mounting the cooler onto the board. Now the cooler is held in place by 4 large screws and grommets placed on the opposite side to hold the bracket in place, and the grommets hold the screws in place for that. Then 2 more zigzag brackets are put onto that, and then the whole assembly sandwiches the board. And so now we're going to go ahead and attempt to get this bolted on here. So the way that we do that is we already figured out the alignment for the cooler here, and it's going to sit right about there on top of the RAM. And what we have to do is we have to mount the bracket here in between the fan and the cooler and push it onto the little studs that secure it down. So we're going to try to get a really skinny screwdriver in between the blades here and see if we can't do that. So these are the bolts that we went ahead and installed and screwed in with the screwdriver going through the fins of the propeller here into the screw head. So what we have to do now is secure these 4, which go all the way through the motherboard onto the back plate we saw earlier. And you also want to make sure that these bolts are all the way through. This one here is a little bit low, as you can see, because I can get my fingernail in there. So I'm going to actually try to get that worked up inside the hole that it corresponds to, so it doesn't hit the case of the computer when I'm doing it. Now, a very common mistake that some people make when they're mounting their motherboard into the case is they forget to put the I/O shield in first. So that's what we're going to start out with, obviously. So we got the I/O shield here, and it's going to go right into the back here. It is time to mount the motherboard itself. And the way we mount the motherboard itself is we take it I/O shield first, which would go on this side where the input output is, and we push that right into the corresponding holes of the I/O shield we just installed. And what that does is it lines up the motherboard, for one, so that we don't have it cockeyed, and 2, it keeps the I/O shield itself from popping out. Now this is a little bit of a tight fit because it is a fairly small case, but we're gonna just give it a little bit of a push here. It's got to get underneath this lip right here and line up. Line it up with the holes, and then realize that the screws from the last motherboard were left in there so you wouldn't lose them, and do the whole thing over again. took it out, put it back in, and we're gonna go ahead and put these pesky screws that kept us from getting in there fine last time in there now. Oh, look at that. No problem like a charm. My gosh. Might have to take the CPU cooler off to do this, because I gotta get the 24 pin connector. Sheesh. This stinks. That's what happens when you have such a small case requirement. You gotta live with your choices. Okay, so we're gonna plug in the 24 pin connector now that I got the CPU cooler off. Alright, we also went ahead and plugged in these rear fans that exhaust all the CPU out, and it kind of routes around the inside back here of the case. We're going to go ahead and also plug in the 8 pin. So now we have all 3 SATAs plugged in. We also should probably do the front panel connectors. So the front panel connectors are what gives your front panel buttons, such as power, reset, the LED lights, things like that, a place to get their signals from. And those correspond to these here. These are very long. I don't know why they decided to make these this long. Maybe they're left over from a different Silverstone case, but these are longer than they need to be. These are the front panel headers on the ASRock motherboard. They're just on the side of the RAM sticks, and they are where your front panel lights, buttons, switches get their signals from. So we have these tiny little cables, and what we're going to try to do is line them up with how they're assembled on the board. Consult the manual that comes with your board. So if this doesn't work out, we'll have to find a manual. But that's the header pin out there. Now that we have the everything plugged into the board, we have to put the CPU cooler back on. And this should be interesting to say the least. So what I'm going to try to do is lift this arm up and out of the way. I'm going to put this down in there on top of the CPU, of course. Make sure that it's in position, and then I'm going to try to move the arm back into place. Okay, so now that we've got the cooler in there, we've got all the cables managed as well as we can be. The ones that are out still are for the hard drives and the video card, so we will do those in just a minute. But speaking of video card, we're going to go ahead and put in the video card bracket that has the SSDs on the back and the video card on the other side. Now, as you can imagine, the RYZEN card here goes into the PCI port here and fills in this gap. It's got this nice hole on the bottom of it here that we can use to run the PCIe power cables to the video card. So go ahead and plug those in now while we have it exposed. Put those on the inside of the cable management area here and fit the whole bracket into the case, all while keeping these cables from popping out. See if we can do that all at one time here. Okay, so the system's built and we're just waiting on Windows updates, and there's a couple things that we're actually 3D printing to keep the fans on the inside of the case from hitting any of the cables that are stored next to it. So we're printing a few 120 millimeter fan grills that are going to go on the inside of the case. So now all we're going to do is boot it back up and see if we can't get this thing close or to 4 gigahertz. See what happens. Okay, so we've got our overclock tweaker here, and we'll go from auto into manual, and we'll go from a 3100 megahertz to, let's try 3.8, and we'll up the voltage here. Now the voltage that most people are using is about 1.35, so we'll try that, and if that's stable, we'll try going a little higher. All right, so far so good. Look at that, we're getting into Windows updates. And if I feel the back of the computer, not all that much hotter coming out the back, so that's pretty good. Okay, so we're playing PlayerUnknown's right now to show off, just to see exactly how many frames we can get in a very competitive game. And I'm in the middle of the military base, which is one of the hardest places to render, especially with how many people dropped here. And I didn't have any buildings not load correctly. I didn't have floating heads rolling around, which you can find in lower end systems. Right now, what I have for settings, I set some custom video graphical settings here. So I've got the screen scale all the way up to 120, anti-aliasing down to very low, post-processing at medium. I turned the shadows all the way to low, but for texture and effects, I kept them at high, foliage at very low, and view distance to ultra. I want to be able to see people sniping me from a ways away. And with those settings, I'm getting upwards of 50 FPS. If I turn the screen scaling to 100% instead of 120, that bumps all the way up to 60 to 70 FPS looking out at great distances. Like right here, if I'm looking straight out, I get 70 FPS looking about a kilometer out. So that takes a lot of video RAM, which we have 8 gigs of with this RX 480. So definitely a doable card. There's very little stuttering or anything like that. If I move, there's a bit here, but that could also be the television I'm playing on. So hopefully that tells you a little bit about what we're up to. Let's see if I can get this guy. Nope. As far as our overclocks go, we weren't able to get to 4.0 as we hoped. We got to 3.8 gigahertz on this rig at 1.35 volts on the CPU clock. So pretty good. It's pretty much what we had expected, and we're gonna stick to that. I couldn't get it to boot past 3.8 gigahertz whatsoever. So I think 3.8 when the stock is 3.1, and if you think about it, that is higher than the base clock of the 1700X. So I'm pretty happy with just shy of our goal of 4 gigahertz. And I'm gonna try gaming on this for a while and just see how we do. Wish me luck, and if you want to have any other questions about this board, again, this is the ASRock Fatality. This is the B350 ITX board from ASRock, and big shout out to ASRock again. Thank you very much for sending this our way. We weren't really trying to build a console killer in this. We were trying to just make a very portable system. So if you're at DreamHack Denver, or you're coming out to LAN-a-thons or LANs here at the HQ, feel free to say hi, check out the rig, be happy to tell you more about it, and you can give it a shot yourself and just see how portable this little Raven case can be with these high-end parts in it. Anyway, thanks for watching. Please share this video if you found it interesting, and hit the subscribe button for more content. And of course, give us a like or dislike, or post some comments in the comment threads. We've had a lot of great comments about what videos people would like to see, and we'll make those our content. So thanks for watching. Let's hope I don't die while crossing the bridge. Thanks. Bye.